Hello everyone, so today we are going to solve today's daily Leetcode problem, which is 2616, minimize the maximum difference of pairs. So basically in the question we have given a zero index integer nums and an integer p. So our task is to find p pairs of indices from nums such that the maximum difference among all pair is minimized. Okay, and we make sure that no indexes appears more than once. So basically we have a array and we have a p value. So what we need to find is we need to extract two pairs of elements or two pairs of index where the absolute difference will be minimum, and then finally we will pick the maximum of all those absolute difference which we have find out. For example, if p equals to 2, so to get the minimum absolute difference, what we can select first is 1 and this one. Okay, so index 1 and index 4, so we'll get the absolute difference is 1 minus 1 equals to 0, so it is one pair. And another pair we can select is index 2 and the last index, so the difference we will get is 2 minus 3 is equals to 1, absolute difference is 1. So two pairs we have got and the absolute difference are 0 and 1, so we'll pick the maximum of these two pairs. So we'll get the maximum of 0 comma 1 is equals to 1. In the second example, we only need one such pair which has a minimum absolute difference. So we'll select this 2 and this 2 index. So we'll get the absolute difference is 0. Okay, so these kind of questions are the tricky one, but if we figure out the pattern, so whenever we have this kind of things, minimize the maximum difference or maximize the minimum difference, so it's a kind of binary search pattern, and where we need to apply the binary search on the answer. Means what is the minimum absolute difference we can get here is 1 minus 1 0, and what is the maximum we can get is 10 minus 1 equals to 9. So we are make sure that our answer is lies between 0 and 10 minus 1 9. So similarly we will apply the same approach. So let's see the code. So it is the boiler template for all the questions which have kind of minimize maximum or maximize minimum. So what we do, we simply sort the array first, because the indices order doesn't matter. The only thing which matters is we pick two distinct element which have not picked earlier. So what we take left 0 and right as the last element, and we will start from the right. So as we are traversing for minimizing the maximum ones, so for example our scale is 1 1 2 3 4 5. So let's suppose our array is this, so we are initializing our left pointer to this one and the right pointer is this one. So as we are targeting for minimizing the maximum ones, that's why we have started our answer from the right index, and now we are minimizing it. So every time we will do some stuff and we'll see if this stuff is okay, then we will shift our right pointer to the left. So similarly we have done here. So we have taken a loop from left while left less than equals to right. So every time we are calculating mid. In this case the mid is let's say 2. Okay, so if we can see, we will check if by a function if this mid value is okay. If the mid is okay, then what we do, we will update our answer, and then we will shift our right pointer to mid minus 1, because it is the minimizing of maximum. So we have started from this max, and now we are pretty sure that 2 will be one of the valid answer. So we have shifted our right pointer to this, and similarly we will go to the left until it is valid, so it will be the minimum result. So same we are doing here. Every time we are calculating mid, and somehow we are checking if this is valid. Means from the given nums array, the if we have at least p number of pairs which do have absolute differences mid, so we'll take the answer, we'll update our answer as mid, and we'll shift our right pointer. And if it is not valid, means we have to move our left pointer to the mid plus 1. So we have done here. And what if it is about the maximum of minimum? So we have started our answer from left, and whenever it's valid, so we would have updated our left equals to mid plus 1, and then similarly right equal to mid minus 1. So that is for maximum of minimum. But here, as we need minimum of maximum, so we are starting from the right, and every time we are getting valid as mid, so we are updating our answer and we are shifting the right pointer to mid minus 1. Okay, so this is the same boiler template which will be applicable for all these questions. So the only thing which vary is the valid function. So as per the question, we need to implement our valid function. So if we come here to valid, so it is pretty simple, as we have already sorted the nums array. So we are getting a sorted nums array here. So what we are trying to count, so as in the valid we have passed p and mid. So now we have to check if in the nums there are at least p numbers of absolute difference which have a minimum value of mid. So same here, we are counting. So first we are initializing count variable to 0, then we are looping from I equals to 1 to last index, and every time we are checking this nums of adjacent value, and if their absolute difference is max diff, and max diff here is mid. Okay, and so if it is valid, like if we have a difference which is less than equals to mid, so we can increment our count variable. And here we are again increasing I plus plus. Why we are doing it? Because in the question we are given that no index appear more than once among p pairs. That means no two elements can be picked twice. So let's say my example, so if we have a array 1 1 1 1, okay, so if this pair is valid, that means we cannot select this pair. Why? Because this one will be overlap from both these two arrays. That's why we are incrementing I plus plus whenever we count this, whenever we find this condition true. Okay, and at last we are checking if our find number of pairs which have the difference is less than equals to min is greater than equal to p, like so this case is valid. So whenever it is valid, it will return true, and then we will update the answer and shift the right pointer. So let's run this. Okay, so it's valid. Yes, that's working fine. And one more thing, there can be a doubt why we are only comparing the adjacent element. Why not comparing from 1 to 3 instead of why not we are comparing this 1 to this 3 directly? So as question, we are targeting for minimum absolute difference, and we all know that if the array is sorted, so the minimum difference will be get by the comparing of adjacent element only. So that's why we have only compared the adjacent element. Okay, thank you so much.